This is homework set 6, linear inequalities, but now we'll look at questions 6 through 10. Question 6, we've got a negative fraction multiplying the x. Now the way I'm going to handle this is, if there's a negative in front of a fraction, I like to write it on the top. So I'm going to write it as negative 1 over 3x strictly less than or equal to 2. Now, here's what I see. I see a multiplication, negative 1 times x, and then I see a division, divide that by 3. So I'm going to undo the division first, and I'll do that by dividing, not dividing, what am I thinking here? I'll multiply, right? It's dividing, so I'm going to multiply by 3. Now, alert, I've got an inequality and I'm multiplying, so I have to check. I know if I multiply or divide by a negative number, the direction of that symbol will change. But I'm multiplying by a positive number, so no problem. So let's just write 3 times negative 1/3 x less than or equal to 3 times 2. Now on the left side, 3 and the 3 is once, so I'll just get negative 1x less than or equal to 6. Now I see I've got a multiplication. I'm multiplying by negative 1, so I'll undo that with a division by negative 1. Alert, now I'm multiplying by a negative, so I need to change the direction of this symbol. So when I write this, I'll write as negative 1x over negative 1 greater than or equal to negative 1 times 6. Now negative 1 divided by negative 1 is 1, so I get x is now greater than or equal to negative 6. There we go. And if I graph this, I'll draw a number line here. I'll label it x. Now, the inequality is got an equal sign, so it's included, equals included. So I'm going to I'll indicate this with a closed circle, saying that that negative 6 is included. And now we're looking for all the x's that are to the right of negative 6. So that's all of these, right? If I pick any point in here, right, pick any point in there, that number is greater than negative 6. And where would 0 be? Well, 0 is over here someplace. Question 7, I've got this linear form over here, so linear inequality. And I'm going to treat this as if it were an equation. The only difference is, when solving, if I multiply or divide by a negative, the direction of the inequality sign changes. So just treat it as if it were an equation. So what would you do? You have to eliminate the negative 5 and the 6. Now the negative 5 is multiplying the x. The 6 is being added. So I'll undo, right, order of operations, multiplication, addition. I'll undo with the opposite order, undo the addition and then undo the multiplication. So first up, let's subtract 6, right? So subtract that 6. I'll write the whole thing out. 5x, negative 5x plus 6 minus 6 greater than or equal to 16 minus 6. Now that is a 0, so I can just drop that, because negative 5x plus 0 is negative 5x greater than or equal to 10. Now let's eliminate that multiplication by negative 5. So I'll undo a multiplication with a division. But alert, I'm dividing by a negative, so the direction of that symbol is going to change. So I'll write it out. Negative 5x over negative 5 is now less than or equal to 10 over negative 5. That's a 1, so I'll get x is less than or equal to, now, positive 10 divided by negative 5 is negative 2. That's what we're looking for. So all the x's, if I choose any x, negative 2 or less, and put it back into the original statement, we'll get a true statement there. Question 8. Let's see what we can do here. Now we've got fractions. So with these fractions, I always do these the same way. I'm going to eliminate the denominators by doing this. I'm going to find the LCD. Now the LCD is the least common denominator, so I just think this. Look at these denominators, 2, 10, and 5. And I ask this, what is the smallest number that 2, 10, and 5 divide into? So I'll write it here. Here's what I always ask. What is the smallest number that 2, 10, and 5 divide into? Now that number is, you can always get it like this. Just start with the biggest one, 10. Does 2 go into 10? Yes. Does 5 go into 10? Yes. So in this case, we didn't have to do too much work. That LCD, L for the least, the smallest, is 10, right? All of those numbers, all three numbers, go into 10. And 10 is the smallest one that they all divide into. Now, be careful. I'm not asking this. What is the smallest number that divides each one? I'm not asking that. I just want the smallest number that each one of these will go into. Then what I'm going to do is I'm going to multiply both sides by the LCD, all right? Multiply by the LCD. So that's going to look like this. 10 times this left side, which is 1/2 minus m over 10, right? 10 times the left side, greater than or equal to 10 times the right side. Now that LCD is positive, so because it's positive, I don't have to change the direction of that symbol. Now on the left side, we need to eliminate those parentheses, so I'm going to multiply through here using the distributive property. So I'm going to get 10 times 1/2 minus 10 times m over 10. That's greater than or equal to, now just do this one. 10 times 4 is 40. 40 divided by 5 is 8. Or, if you like, 5 into 10 is 2, times 4 is 8. Now, let's just stop a minute and reflect on what we did here. Because what I'm going to do is I'm going to show you how to skip this step here. Well, you don't have to write all that. What are you going to do? Back here up at the top, you're going to multiply by the LCD. So what did I do? I multiplied both sides by the LCD, right? The left side and the right side. But look where that LCD ended up. It ended up in front of the first term. It ended up in front of the second term, right? So where do you put the, I'm saying I can skip this step if I just do this. When you multiply by the LCD, just write the LCD in front of all the original terms, right? Like up here at the very top, the LCD is 10. Write the 10 here, the 10 here, and the 10 here. And it works because I'm multiplying both sides by that LCD and using the distributive property. It's just that I don't need to write every single step. Now, what have we got here? 2 into 10 is 5. 5 times 1 is 5. Minus 10 to 10 is 1, so I just get minus m, greater than or equal to 8. Now, we're close. So now I'm going to subtract 5. So if I subtract 5, now just do it. If I just subtract 5, it's gone from the left. I get negative m greater than or equal to, now I'm subtracting 5. 8 minus 5 is 3. But now what I've got is that the opposite of m is 3. I don't want the opposite of m. I want m itself. So why don't I just multiply or divide? All right, I'll do a division here. I'm going to divide by negative 1, right? Because really, what is this? This is negative 1m greater than or equal to 3. So divide by negative 1. But if I'm dividing by negative, so it changes the direction of this symbol. So I'm going to get m now is less than or equal to 3 divided by negative 1 is negative 3. And if we graph this, now not x this time, we got an m, and the inequality is got an equal in it, so I'm going to draw a closed circle, and I'll label that negative 3. I want all the m's to the left, yeah, because the arrow points to the left. And if I want a 0, negative 3 is to the left of 0. So there we go. Question 9, we've got fractions again, so let's get the LCD. So the LCD here is, now think, what is the smallest number 3, 9, and 12 go into? So the way I do it is this. I pick the biggest number, 12. Now, does 3 go into 12? Yes. Does 9 go into 12? No. So double, triple, keep on going until they all work. So double this. Does 3 go into 24? Yes. Does 9? No. Triple it. 36. 3 goes into 36, and 9 will go into 36. So I've got it. So the LCD here is 36. So the plan is to multiply by 36. Now, I'm going to multiply by 36. And we saw in the last problem what happens is that we can shortcut a little bit by just writing that 36 alongside each one of the original terms. Now, the direction stays the same because we're multiplying by a positive number. So I'll write the 36 in front of each one of these original terms. Well, this is interesting that they wrote 2 over 12 instead of 1 over 6. But anyway, that's what they did. So I took the LCD, I put it here, here, and here as a multiplier. Now when I divide, all those denominators will cancel. 3 into 36, that's 12. 3 into 36 is 12, right? And then I get 12 times 1, which is 12. That's greater than, now, 9 into 36, right? 9 into 36 is 4. And then what I get is, okay, 9 into 36 is 4. 4 times negative 1, negative 4. And now, 12 into 36 is 3. So I get minus, let me get it right in here, minus, all right, 12 into 36 is 3. 3 times 2 is 6. 6x. Now, here's the x on the right side. So I need to eliminate the negative 4 and the negative 6. So I'm going to start this by adding 4, right? So my plan is to add 4. So if I add 4 to each side, now I'm just going to go ahead and do it. Add 4, I'll get 16, greater than. Add 4, negative 4 plus 4 is 0, that's gone. And so I'm left with negative 6x. Right? What I did is I added 4 to both sides. Add it here, add it to the left side, add it to the right side. Now, get rid of that negative 6. It's multiplying, so the plan is to divide by negative 6. Alert, I'm dividing by a negative, so I'm going to change the direction of that symbol. So I'm going to get, I'll write it here, I'm going to get 16 divided by negative 6 is now less than negative 6x over negative 6. Now, negative into positive is negative. Doesn't go evenly, but I can divide both by 2, so I'll get 8/3 is less than, those will cancel, x. Now, this has happened to us before. This is just a little awkward in the sense that if you're asked, what is x? And you say, well, negative 8/3 is less than x. It's just awkward, right? So here's what I'm going to do. I'm going to rewrite this like this. I'm just going to turn everything around. If negative 8/3 is less than x, right, if this is less than this, then the x must be greater than negative 8/3. Does that make sense? If negative 8/3 is less than x, then x must be less than negative 8/3. It's like if you are younger than I am, then I am older than you are. There we go, we've got it. Number 10, well, let's see. I've just got one x over here. Why don't we eliminate the 10? So what I'm going to do is I'm going to subtract 10 from all three sides, from both sides. So if I subtract 10, just go ahead and do it. Negative 20 minus 10 is negative 30. Less than or equal to, now, if I subtract 10 on the right side, that 10 is gone, and I just get negative 20x. Now what I'm going to do is divide by negative 20, right? Here's my plan. Divide by that negative 20. Alert, change the direction of that symbol, so I'm going to get negative 30 over, divided by negative 20 is now greater than or equal to negative 20 x over negative 20. Now, on the left side, negative divided by negative is positive. I can divide each by 10, so I'm left with 3 halves. So I'll get 3 halves greater than or equal to x. But as we did before, I'm going to turn this around. 3 halves is greater than or equal to x. Just turn it around, like x is on the left side. So x is, now everything gets turned around, less than or equal to 3 halves.